Liquidshop4 and what's back and forth. So every time I try to find a fancy title, but essentially, I think the purpose of that presentation is to look at what we've done and what we want to achieve in the next 12 months. Yeah, so we'll do a general update, what happened since the last Liquidshop, and what is remaining on the roadmap for the next release. The general update is that we've done a lot, and not necessarily a lot that was functionality and fancy functionalities. Because if you look at the past couple of years, really we added like records and really enhanced the language so that it really now is fully functional. We added FFmpeg support, which is huge amount of new functionalities. We had stereo tool was integrated. We had all this fancy feature. And a lot of the things that have happened in the past year are more about making things more usable. And a lot of the things that are going to be coming up are about making things more efficient. I think that I was thinking about it when you grow up as a software engineer. You know, the joke is that the junior software engineer who just started is like, whoa, I made a website and it works incredible. And then the senior is like, yeah, no, I can make your website work. That's not a problem, but how do I do it in a way that's solves all these problems ahead of time that I'm aware of because I've done years of that work. And so that's where we are. So we were a bit junior in the past couple of years, adding a lot of new stuff. And now it's the time for the maturity to be like, okay, let's make it work the same, but better. And I'm going to talk about it. So also I want to say another big update that I'm very excited to see being presented is that we are seeing a lot more traction from the community, and we've been seeing some very significant collaboration and contribution. And that is very important to us because it really helps us focus on the things that we can do better. And also, we're not all expert in every single details of radio concerns. And so when other community members step up and tell us how they want things to work and actually make it work the way they want, it's really enjoyable. And we have an example of that with AutoQ and the crossfade that I think Matthias is going to talk next. So thank you. Yes, any questions? There'll be questions. So here's what I closed the last presentation last year with, was the roadmap we envisioned for the year. So let's see a review. Update the Liquidsoap book. Well, it's pending. We still want to do it. It's a lot of work. It's a matter of focusing on it. I think the book is still usable. A lot of people enjoy it. But truly, yeah, there needs to be an update. We have rewritten the streaming loop. I'll get into it. We have rewritten the clock implementation. I'll get into it. We could not fully take advantage of OKML number 5, version 5. I also will get into it. The proper module support has been paused because we found better ways to do what we wanted to achieve with it without having to do major breaking change. And I think one of the feedback we're getting is that our users are getting a little bit tired to have to rewrite their script extensively between versions. So even though having a proper module support would be awesome, it would also change a lot of things. And so for now, no. Address the standard library performance issues. We're going to talk about it. This is the exciting work that's been ongoing. And add the developers tooling for syntax highlighting, prettier linter. This is done, and it was a ton of work. So I'm going to start with that. So what is developer tooling? Well, essentially, since the language now is very fully featured, one of the things that was getting important is to help users of the language and make their life easier. The kind of tools we're looking at is Prettier, which is a formatting tool to get your code to like look standard and also be standard across commits. We use it typically, all our commits are automatically formatted now so that the change are really just the change you want in the code. It removes all the white space, standardize a lot of things. Syntax highlighting, the tools for that we have actually implemented are tree seeders and Commir. There's a little bit of VS Code, another one for GitHub. I'll get into it because that thing, as you will see, everybody has their own implementation and it's gnarly. Yeah, so formatting, highlighting, linting is not there yet. Linting will give you hints at things you could do better. It could be another tool we can develop in the future, but as I explained, we spent a lot of time already on that, and I just don't want to spend my life on it. So Prettier, that's the first step we did. I want to explain about how it works because I think it's interesting, um, just to understand the complexity of it. So we start with the parse term. So parse term is something like this, which is basically an expression of the language. Here is the call to the function add from the list module with two arguments, x and l. And this is what we call a parse term. It's really just a representation of a language uh, term expression. So first thing we do is we parse it, which means that we create a little programming version of that. So here you see we are invoking the method add from the variable list, and then we apply it with those two variables. And then the thing we need to do next is to be able to print that out. Well, we need to execute it. That's the first thing. So what we do in the language, what we did before the change is we would compile that into, see, I should have rehearsed this. We compile that into a runtime term that looks like this. Oh, okay. It's the morning, y'all. I'm going to go back here. All right. So once we have our parse term representation, we want to be able to expose it as a formatted thing. So the first thing we did is that we added a new layer that had every single form of syntactic things from the language that we could store as a representation of a language term. And the thing that's cool with that is that we can use that immediately to reprint the script the way you wrote it. So we have three different definitions here for definitions. Because we can do def, we can do let, or we can do x equal. They are all represented here, and then we will use that eventually to print your script. But on the other side, what we need to do is turn that into something we're going to execute, which is a runtime term, which is a much shorter version of the parse term. So if you look at this, there are like 30 different cases for every single syntactical construct we have in the language. This gets compiled into a shorter run term that is this. It looks a lot, but it's actually not. Typically, there's only one form of let. That's what we execute internally. So how does it look? It looks like this, but if you want a little explanation, this is a string interpolation. Remember, it's a string where we insert this here, variable, we insert here, which is a function application, and we create a string out of it. So this gets compiled into this. That's also Liquidsoap language. So the concatenation of the string version of that variable plus the space plus the string version of that plus the latest part. And so what's happening is that this exists in the syntax, but it never actually exists when we run the script. When we run the script, we are operating in a much smaller subset. So once we have this bridge, and here we have a very abstract representation of a term, the other thing we can do is export it as a JSON that really describes your script in every single detail. And from that JSON, we can plug it into a pretty printer that's going to take all the three different definitions of let, def, and binding and reprint that as a script. And so this was implemented in JavaScript. The reason is that there is a very convenient library from Prettier, which is the JavaScript pretty printing. Also, I'm familiar with it, and so it's good to not have everything in OCaml. So that was the first tool we did, is the Prettier tool. It's a command line. You can take a script, and it's going to export your script pretty printed, and you can write on, you can rewrite the file in place. It's a lot of work. Then we had to integrate it into editors. A lot of work, and everybody has their own editor. This is the integration for NeoVim, and for only one plugin of NeoVim. So multiply that by the number of editor and the number of plugin. That's a lot. Please add support for your favorite editor. Then we did Treeseeder. Treeseeder is the grammar for Liquidsoap. Well, it's a grammar to support syntax highlighting. And again, we had to re-implement every single thing that we do in Liquidsoap because it's its own description of the language, it's its own description about how to read a script and highlight it. Entirely rebuild of the whole grammar of the language on how to parse a script. Why? Because that's really cool. So now you can like inspect your script in the editor and see like what are the different nodes in it. It's really cool. The reason we had to do it is because Treeseeder is really good at parsing errors and keep going. We have a parser in Liquidsoap, but it's designed to stop at the first error. This one will detect an error, but still going and be able to use syntax highlighting afterward. It's just a very complex thing to do. But we had to re-implement the whole grammar, the whole description of the language. I'm not going to do a live demo because I'm running a bit out of time. But if you have a editor like NeoVim and set up, you can now type a script. It's going to be highlighted. You can do a little formatting. It auto formats. It's really cool. But that was not all, because everybody has their own tools and everybody does it differently. And so we also had to do Lather. Why? Because Lather is used by CodeMirror, which is one of the major online editor, which is used by Azure Arcast, in their Liquidsoap editing facility on their software. So we kind of wanted them to have a fancy highlighting in it. So Lather is, again, a re-implementation of the language. Entire description of all of it, 34 different cases, 34 different ways, their own ways of doing it, their own quirks. We are our own quirks, full implementation of the language again, a lot of work. The result though is pretty cool. Now we have an editor that's fully syntax highlighted. This is the little Liquidsoap playground. I don't know if you've seen it, but you can do liquidsoap.info/try, and then boom, you have a little limited but usable text editor. It doesn't have all the fancy operators, but it's really good to just do a little try of your script. Then we did VS Code because, again, everybody has their own thing, and VS Code is another one that's used by a lot of programmers. This one has its own grammar, so if you're not familiar, grammar is the way to describe how to read a script. And this one is regex. It's based on regular expression. So if you want to parse an if, you give it a regular expression for the beginning, for the end. You give it a regular expression for what's in between, and then what you need to catch. Frankly, it's pretty horrible and horrendous compared to Trucider and Nether. But again, we did it. A lot of work, re-implementation of the language, probably not perfect, but it gives you VS Code with nice syntax and lighting, which frankly is great. It makes things easier. As is another entire re-implementation of the language. So we are 3 already, complete re-implementation of the language grammar. But that's not all, because you have GitHub. So again, GitHub has syntax highlighting. It's also used to tell you how many repositories have Liquidsoap in them. And it's a regex-based grammar, so same thing as VS Code, similar. We submitted a request for inclusion in the GitHub Linguist repository, but unfortunately, right to scratch, we got denied. It's very frustrating. I think that their terms are very arbitrary, and I'm a bit biased, but their search functionality is actually broken. They don't really index files well, and they told us that we don't have enough files and enough users, and frankly, I think it's a bit garbage, but it was pretty frustrating, and I think that was the end of the road for me, because I'd spent a couple of months re-implementing the language 4 times at this point, and I was just tired of it. So if you want to help us, please commit some of your script file to GitHub. We're at 1900, and we want to get to 2000, so we're really not that far. Please, 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 please. Or feel free to go comment. I don't know. We don't want to bully them. We don't want to be bad actors, but I don't think they realize that there is a whole community of people using it, and it's a bit sad. Jilu.
Yeah, if you're allowing interventions here, maybe we could do something in the community, like you say, like there's a lot of things I do and I have as leak files, and I honestly don't, I use GitLab for my own things, so it's public, but it's not there. So I should just mirror all those repositories with a lot of leak files just straight there. And I'm pretty sure that if we ask the community to, yeah, go ahead, commit something in GitHub, I'm pretty sure that people will do it.
Yeah, so John is saying he has a contact. I'm open to any solution. I was frustrated, so my first remarks were a little bit, frustrated, but I think we need to be kind, but also remind them that like GitHub is a community thing, and we have a big community, and it is a real language used by real people, and it would make a real difference. We have a lot of discussions. The thing I'm thinking is that we have a lot of discussions on GitHub, a lot of issues, and a lot of our users are not programmers, so having syntax highlighting on script extract in the discussions and issues would really help everyone. So yeah, anything we can do, that'd be great. Thank you. All right, let's keep going because I don't want to take too much time. So there's so much more we could do. That's the thing with these things. It's like everybody has their own tooling. There's Discord. We still don't have Discord. It's another highlight.js. I started it, but then it was like I don't want to. I want to focus on other thing. We have linting. The question also is, what else do we not know about that we should know about, and can we get a bit more support from y'all to help us move forward? But that being said, it's pretty good already, and so I'm very happy with this part. Um, Other parts of new things, the internal change that I want to talk about, we completely rewrote the streaming loop and the clocking system. Liquidsoap has been existing for 10 years, and some of the design decisions we had were made literally 10, 12 years ago, when Sam and David at the time were still in their dorm room at ENS Lyon. David actually has a really nice talk about the early times of Liquidsoap in the first Liquid Shop if you want to try it. But then after a while, you discover that some of your early design decisions are not necessarily what's sticking, and sometimes you're stuck with it, especially if the software is big. So that was a huge, huge thing. I'm going to try to talk about it a little bit. The streaming loop was replaced, but we replaced a pre-allocated shared frame model with an extensible content frame. I'm going to go to it. It's a huge cleanup, and it's a better integration with tools like FFmpeg, and it really reflects better how other library works, and so we should be able to interact better with them. What is the streaming loop? Before, we had this little thing here that we call a frame. It's 0.04 seconds of data. And if you look at the first Liquidshop presentation I did, I explained that we have a frame and we pass it around to the different operators and it fills it up. It writes the audio and writes the video, and then when it's done, it sends it. And it really assumes that this is our timeline. And if you use your imagination, it assumes that this is the audio samples and the video samples. And what we want is that every frame, every 0.04 second, has the exact same number of audio samples and the exact same number of video frame. But it's not the reality, actually. What we learn is that this was a model that was developed with audio, because if you have audio, you have 44.1 kilohertz audio samples, and all your samples are predictable along the timeline. But with video, things are weird, very weird, because you have all these things called predictable encoding, where some frames are A frame, B frame. Some frames are going to come before they display. Some frames are going to, it's just, the order is unpredictable. You might have no frame, you might have more frame, you might have less frame. If you have a very action-packed sequence, you have a lot of frame. If it's a slow dialogue and romantic moments, you have no frame because it doesn't move fast. In other words, you're not guaranteed that your frame, here 0.04 seconds, is always going to have video in it at the same time. So what we did instead, we replaced this thing with an empty array of 0.04 second. Then the first operator comes and fills it a little bit. And then it's like, well, I didn't finish it, so we pass it to the second operator, it fills it a little bit more, and so on and so forth. So it's more like an extensible array. And most of the time what's going to happen is that there's going to be the same amount of audio, but this might not be a video frame everyone. Like the first fill here did not add a video frame, the second added a video frame. That's a much suitable system. It also it gives us the possibility to have frames that are below the video frame rate. So that means because before we were stuck to 0.04 second as the minimum frame size, now we can have any arbitrary size for the frame. It's really nice because it impacts latency. It means that the latency can be anything under 0.04 second. The way we do that the reason we have the previous model is we didn't want to copy data. And so the way we do it now to avoid copying data is that we decode a big chunk of data, let's say 3 seconds. And what we put in the frame is the full 3 seconds with a reference to the offset when we start and the reference to the duration, how long it should be. So this thing is a small chunk of data, but it's not copied from the big one. It's just the big one plus positions information. The other thing we do is we put the track marks in it. And I'm not going to get into details, but this is the end of the road for one of the biggest challenge in our original design, which was that we had a confusing overlap of two notions, which was where track marks are and where filling points are, which is basically to say that we filled until this part. They are called breaks. They were called breaks. And I don't know if you have seen the issues for a long time, but we had so many problems around last field didn't add a break. We had problems where breaks were confused with track marks because the two notions were the same. We finally split them, that track marks are track marks and the partial filling of a frame is a partial filling, and so potentially no more bugs with breaks and track marks. But the reason I'm insisting upon that is that when we're going to get to test 2.3, it's possible that some behavior will have changed around track marks and how switch operators go from one track to the next because of this change here. Potentially we'll have different behavior at runtime, which might be frustrating. I want to call for patience from our users because it was a very important change to avoid future bugs, but we will definitely take some help in reviewing what has changed and if it's broken or not. Clocks, I'm going to have to go fast, but essentially it's another part of the thing. It's the little loop that keeps creating frames and sending them to the outputs. Again, that was very old code that we have rewritten. We've rationalized it. We've tried to understand better some of the notions that were inserted because we needed them right here, right now, but we really didn't take a lot of time to think about it. One example is synchronization issues. So here's an example with WWOZ, which Nick Simono is going to talk about, is our beloved Nuance radio, community radio. So that's an input going into an output. And here we have two sources of synchronization because streaming from Icecast controls synchronization. The Icecast server is going to send the data at a rate that's designed to be read, and it tells you like, don't keep reading from me. I'm going to block until you have more data. I'm going to control your real time. But AO is connected to the sound card, and it's also going to block until the sound card has played data. Those two things are not going to play very well if you don't know about it. So we are now able to explain that in a much better way. Clock generic, which is the clock, has multiple synchronization source. We consider that this one here is one synchronization source, this other one is another one, and we're able to report it by saying, here are the sources that have different synchronization. It's input.http and it's AO. We name those synchronization source, even though it's a bit redundant. We say that source has a synchronization source. This one is AO. We give you a stack trace that goes straight into your script, so you can trace to the exact line of code, and we tell you like, maybe you should use self-sync equal false. Yeah. So we hope this is going to be more helpful. The other thing that's cool, live demo, I'm not going to have time, but you can actually query a source to say what is your clock. You can say what are all the clocks that are in the script, so it's more inspectable. And potentially you could run the clock yourself. Exciting. Don't have time, unfortunately. Last thing we couldn't do is OCaml 5. The reason we couldn't do it is because OCaml 5 is a bit young in their new memory system, and it's multi-core and it works. It can clean up memory, but it's not very efficient at it. And what we discovered is that in situation like our application, it has edge case where it will start by generating a lot of memory usage and then drop it progressively. It's really not suitable for us. We're a streaming application. We want to minimize how memory is used. And so we can't use it at the moment. The other thing is we're not yet sure about how to parallelize because it's nice to use multi-core, but frankly, for Liquidsoap, if you run one radio per script, you're already using multi-core. And so it's not really a very pressing need. What was very pressing for us, though, is we want to optimize runtime, and Jilou will talk about it. We have two problems that have happened in the past. We have a high memory usage from the standard library. We have a high CPU usage from the complexity that it is to parse, type, and run a script. That makes it very long to start a script, up to 5 minutes, as we heard. How can we reduce CPU usage at runtime? Well, here's how it works. We parse a script, as I explained, into this. Then we type check it, which is basically asking yourself, does the variable here exist? Does it have a method that's called add? Does this variable X is the right type? It should be, I think, the same type as the list here, etc., etc. So the typing system is really doing a lot of sanity check to make sure that the script is safe to run before we run it. And it's very extensive. It's really great because once you run it, we guarantee you a lot of good things, but it takes a lot of time. And then we're ready to evaluate. And if you look at the runtime, this is about 0.03 second on my computer. This is about 0.02, and this is 3.12. It's like 100 plus times longer. And the thing that's interesting is that once that has been done once, it kind of doesn't need to be done again, because if you have the same library, the same script. Why do it again? Because we know it's safe. So what we can do is cache that, up to 5 minutes with Gilou. So we can cache this and say, let's do the computation once, and after that, let's not do it again because we know it. Okay. So that's what we have that's upcoming. It's a pull request that I've just finished working on. And you can see the numbers here. The first number is about 3 seconds of type checking. The second time it goes from the cache, boom, it's 0.03 seconds. It's 100 times faster. It's almost immediate. And now Gilou is going to be in 2.3. It's a lot of change. And so I'm about to merge that. It's going to make everybody's life easier. We can cache in advance. So if you build a Docker image, you can also build the cache during your build, and then your script's going to run right the hell away immediately. The other thing we want to do is reduce the memory usage. It's kind of similar to what compilers do. We're going to propagate variables. So for instance, if you use list.add again, and you only use the list.add, but list has 34 different functions attached to it, but you only use one. What we want to say is every time you use list.add, we substitute it for the actual function. All the 34 functions that are associated with list, gone. Memory clean. You don't keep that in your memory so that you only keep in memory what your script is using, because it's really awesome that we have a large standard library. But if you use it on a fraction of it, you should just be consuming the memory that's associated to it. So that's the second phase. This has delayed a little bit 2.3, but I think it's very important that we have that. Without it, the release would not be as complete. Other improvement that we want to do, AutoCue needs to be merged back in 2.3. Matthias is going to present it. The other improvement that we've done is the cover manager and video canvas. Video canvas is a really cool way to design video elements that are independent from how big is going to be your video, so you can change the resolution without changing your code. It looks cool. There's a lot of cool stuff happening in video. I don't have the time, but I would refer you back to the blog post we did. And don't worry, there's AI for buzzword. What's really important is the other things. And there's a lot that's missing because 30 minutes is short. When is going to be the release? Soon. We want to do the backport. We want to finish the memory optimization. We need time for performance and regression. And that's where we can use all the help from the community. Thank you very much. I'm 2 minutes late. Sorry about that. If you have any questions, it's time to bring them up. And again, thank you for being here.
Thank you, Romain. So is there any question, remark? You can use the chat or open up the
just
mic.
one here. I'm a happy user of Pulsar, the Atom successor. So of course I would like to have tree-sitter support for Pulsar. That would be really neat.
Cool. I mean, tree-sitter is very reusable. The NeoVim formatter has what they call highlights, which is basically telling you what are the parts that you need to put colors on. I think that can be reused in a lot of editors that support tree-sitter. It would be great if you want to look at it and look at how you can add it to your editor, because the other thing with editors, I don't use them, so I'm not really familiar how they've set up and what is the most popular package and stuff like that, you know. It's Atom, Gilou, or the successor of Atom, I think, the one that GitHub did for a while.
Romain, there was the realization of using meta tags in media files to compile interactive playlists. Last time I checked it a few months ago, maybe even before the new year, it was consuming a lot of memory, and essentially you have to cache the whole thing prior to use it. I think at some point you or your friends rewrote it, and I was just interested if you know what I mean and what is the state of this thing that was supposed to work at some point. I don't remember though.
So if I'm correct, that was Sam's excellent API for keeping track of tracks and songs. I forgot the name of it. And yes, we wrote support for SQLite 3. So instead of storing all the data in memory, they are stored in an SQL database, and I think that reduced the memory footprint a lot. Is that correct, Sam? Playlog, yeah.
Yes, exactly. I think the memory footprint should be much slower, and the speed should be much better, much higher. So I think we kept the 2 implementations even, so for backward compatibility.
Mm-hmm. And someone asked in the chat when we do for the caching pull request, it's a hash of your script without the comments, without the position, so it should be pretty robust in the sense that as long as your script doesn't change in the functionalities, the function you calls and all that, the cache should be valid. Yeah.